talk about operators. So in the last session we spoke about data types. We saw that there are 4 categories of data types: integral type, floating point, textual, and logical. And now we are going to talk about operators. So there are different categories of operators that we have. The categories of operators that we have here is category A is called as unary operators. In the unary operator, plus is the default operator, and you would have seen that we have used plus in a couple of examples. So if you go down to the class variable.java, you would have seen that I have already used the plus example over here. I have said id plus, then I put it into a string, and then I send again plus. So ideally, plus operator is overloaded in Java. So it acts like a concatenation operator when either side of the operator is a string, as well as plus traditionally is a well-known mathematical addition operator. So the plus operator is overloaded in Java. So that is what is the first of the types. This is going to be a pretty extensive topic, so we wouldn't be seeing the examples of all of the different possibilities that we have here. The idea is to let you know what is available so that you can look at your complete reference. You can look up a head first Java to play around with it a little bit more, and it should be there in your mind that okay, there is something of this sort also present. So the first operator is the plus operator. Then we have got something called as plus plus and minus minus, that is called as the pre-increment or the post-increment operators. So pre-increment would mean the value would be incremented before it is assigned, and post-incremented means it will be assigned and then the value will be incremented. So that's the second type. Third of your unary operators is the sleeping S, or it's called as tilde, which is actually a bitwise inversion operator. So what it does is it converts the values of the numbers whatever you're writing into an ASCII value, and it will convert the bitwise 0 to bitwise 1. So it will do a bitwise inversion. And the fourth category of your unary operators is the exclamation one, that is called as a Boolean complement operator. It is typically more popularly called as the not operator. Not operators, it's called as a not operator. And then we have got a typecast operator, which is for forcibly adding a larger size into a smaller size. So remember, in the last session I said I'll be covering this up. So let me go back to my data types and let me show that to you. So we know that whenever I declare it without an F, it was giving me an error because it was considering it as a double, and double cannot go inside a float because the range of it or the size of the double is 64 bits, whereas a float has got only 32 bits. So if you want to forcibly put a larger size type into a smaller size, you will have to say that float variable and you will have to typecast it. Typecast is always putting into a bracket so that that particular value is being forcibly put within the range of what this value is going to be, and so that it can be assigned to the value type that is there on the left hand side. So typecasting needs to be done very carefully. If you do typecasting without taking proper care, it might give you a lot of unpredictable answers. So a simple example of unpredictable answer typecast would be, supposing if I say int a, or let's say byte, you know the size of the byte is from minus 128 to 127. If I say byte a is equal to 10, and I say byte b, okay, there should be variable a1 and b1 is equal to 13. Okay, then I say byte c1 is equal to, I will typecast it into a byte of a1 into b1. Okay, and I put a semicolon. Okay, and then let me write my sys out over here of my c1. So C1 looks to be already there. So let me say D1. Apologies because I'm trying to use a variable that is not there earlier. There we go. Okay, so we have got a byte variable of 10, we have got a byte variable of 13. 10 into 13 is going to be 130. 130 will not go into a byte. You know that because the range of a byte is of the integral type is from minus 128 to 127. So what am I trying to do? I'm trying to do typecasting over here, forcibly putting a larger number into a smaller number. So now let's run this and see what happens. It gives me an answer of minus 126. So how in the world did it get that answer? The way how it got the answer is the range of a byte is from minus 128 to 127. Anything that goes beyond the range, will come back to the LHS, will come back. That means anything that goes beyond 127 will come back like this. Okay, will come back and stop at the position which is the value. So here our answer is 130. So it will go down after 127. It will come down to minus 128, which is 128. Then minus 127, which is 129, and 130 is minus 126. So the ball will stop over there, and that's how you get the answer of minus 126. Okay. So in case if you say 14, and let me save this and let me run this, it will be minus 140. So it will go 10 bits number more, and you see it coming as minus 116. So that's why you have to do typecasting with a lot of caution. It is not going to be a straightforward typecasting. You'll have to do it with extreme caution, folks. Okay, perfect. So that's about the typecasting part of it. So we have seen what is the unary operators. Now, the second category of operators is called as arithmetic operators. Arithmetic operators is the mathematical term that you would have done in your maths long time back when we did our studies. BODMAS, brackets of division, multiplication, addition and subtraction. So you will have all of the standard values, and plus we also have got something called as modulus. Here there is no plus here. Let me put in my plus. There we go. So we also have got something called as modulus. Modulus is ideally the remainder. Okay. Then we have got shift operators. We have got a left shift operator. We have got a right shift operator. These shift operators also work on the bits of the variable. So you should know the binary thing to understand how does the bit work. So it will simply do the binary calculations. Then the category 4 is called as bitwise operators, or else it's also applicable for the logical operators, where 1 is considered as true and 0 is considered as false. And the different bitwise operators that we have is an AND, a OR, and a XOR. The cap sign what you see is ideally a XOR. So what is the rule here is, for a AND, 1 and 1 will give you 1. Anything else will give you, I should say not or, I should say anything else will give you 0. For a OR, the rule here is 0 and 0 will give you 0. Anything else will give you a 1. For a XOR, just one sec, Control Z, a 1 and 0 or a 0 or 1 will give you 1, and if it is anything else, it will always give you a 0. So this is the plain mathematical bitwise operators. Okay, so it is used in encryption algorithms. You need to know this because we have to discuss about the short circuit operators. So we have got something called as double AND. Okay, so double AND and double OR are the two short circuit operators. So these operators always check the left hand side of the operand and then decide should I or should I not check the right hand side. So the rule for the left hand side double AND is that if the LHS is false, the left hand side is false of a double AND, then the whole answer is false without checking the RHS. But if the left hand side is true, it will check the RHS and act like a normal AND operator. Okay, but if the LHS is true, then it will check the RHS also and act like a normal AND operator. So let's take an example of this, folks, so that you can understand this. So we are finished with our data types. Let's talk about our operators. So what I've done over here is to make you work with a normal operator. What I have done is, there we go. This is how it was there originally. Okay, because I have commented it as, you know, when it gets an error, I typically comment it and show you what the error is. So I've declared two string variables. I've declared a string variable with string s is equal to null, and I'm saying string s1 is equal to double quotes. That is going to be, in the first case, null means no memory location. It does not even have a memory. But when I say double quotes, it has got a memory which is empty. So it's very important to identify between no memory and an empty memory over here. And then we say, if s is not equal to null, I'm having a condition. I'm having a normal AND operator, which means that it's going to look at both the LHS and the right hand side. And then I'm going to say my s.length. Length is a method in the string class which will check the number of characters that you have for a string. If it is greater than 0, okay, I am having a if condition wherein it will print me system.out.println, and outside the if condition I'm going to print out outside f for us. And let's try checking this out. So we know for a fact that s.length is not there because s does not even have a memory location. So let's see what happens when there's no error when I try to compile it, but when I try to run this, you will see that it will give you something called as a null pointer exception. You are going to get a lot of null pointer exceptions if the value is going to be null. That means if you have got an object which does not have a memory and you call a method on that empty memory location, it is going to give you null. So that's why it's giving a null pointer exception. So see here, if no memory is allocated to an object, then no methods can be called on that object, and here a single AND will give me a null pointer exception. So what did I do? Let me comment it. And now instead of a single AND, I'm going to use a double AND. So in the case of double AND, what will happen is that, see how it is looking at these things and giving an error, and if you take the mouse on top of that, you see that this is dead code. That means this code is never going to be executed. That's fine. Okay, because I wanted to see this. So earlier in a single AND, it was giving me an error. Now let me run this, and at least it doesn't give me an error. It goes outside and it prints out this. So there's no error that is coming over here. So this is the difference between your normal AND, which looks at both the sides. Same thing applies for a normal OR, and a short circuit AND, where it is going to first check the LHS and then decide whether I should or should not check the RHS, folks. So this is about the operators part of it. So that's what we have seen, folks. Then we have got something called as a comparison operator, and comparison operator always returns to you a Boolean value. It is only going to tell you whether it is going to be true or false. So we have got two comparison operators that is going to be very frequently used in our Java coding. So the two comparison operators that we're going to use is double equal to. Double equal to is typically going to be checking for the memory location comparison. Okay, where the memory is going to be located, and there is a method called as dot equals, which will do the comparison in the string thing. So before even we get into that, so we need to know the basics of how the values are stored in the memory. There are two parts in Java. Something called as a stack, where all the data types are stored, and something called as a heap, where the objects are stored. Okay, so all the classes in Java always inherit from a class called as java.lang.object. So we have downloaded the documentation. Okay, so let me go back to the documentation, and in the documentation you will see that there is a class called as a package called as java.lang, and please note the java.lang package is always imported by default by the compiler. Okay, so we don't even have to. You would have seen that in a C, if you have ever seen a C code or a C++ code, we always import our header files right at the beginning. So you would have seen that in all the codes what we have done till now, we have just kept a package, but then we haven't used anything called as import at all. Okay, so the reason is because the java.lang package is always imported by default by the compiler, and you will see these are the various classes that is there in the java.lang package. Everything that is the basic is from the language perspective is over here. One of the classes in the java.lang package is object class, and you can see over here the object class is the root of the class hierarchy. So you will have to see this kind of documentation in your MapReduce when we go ahead with the coding. All of your packages will be here on your left hand side. When you click a package, all of the interfaces and classes will be shown over here, and when you click on that, it will give you the description of it. So you can see also over here that every class has object as the base class, okay, and all objects implement the methods of this class. And in this class there is a method called as equals. So let me go down to the equals method. There we go. So what does it do? This indicates whether some object is equal or not equal. So it is very important that you understand what is this. So the equals method implements the most discriminating possible equivalence relation between the objects. That is for any non-null reference, that means for a value where there is memory for values x and y. This method returns true, and returns true if and only if x and y are the same objects. That means it is even the equals method in the object class is going to act like double equal to. Okay, so we'll see over here what is double equal to is memory comparison operator, just to check where the memory is going to be stored, and equals method is for content comparison in the string class. Other than the string class, equals also checks for the memory location. So let's look at this. So see here, all the classes in Java always inherit from java.lang.object, and the equals method in the object class also checks for the memory location, but is overridden in the string class to check the contents. So what do you mean by overriding? We have seen it earlier. Overriding means the subclass will have an additional method on top of what we have already written, which will implement a different behavior. So let's go back to this. And you would see over here, if I go down to the string class, I'll scroll down. There we go. We have got the string class over here. In the string class, if I scroll up, you will see that there is a method. This is the constructor. You will see that there is a method called as equals. It's in C, D, E should come here. There we go. Okay, what does this do? This compares the string with the specified object. The result is true if and only if the argument is not null and a string object that represents the same sequence of characters as this object. So that is what is this equals class doing, folks. Okay. So that's what we have seen over here. So this is just to let you know how the java.lang package is always imported by the compiler. So let's go ahead and see an example of what we just saw right now. So let's go ahead and see. There should be a variable, there should be something that I have done for the string equals. Just one sec. I'm just trying to, there we go. This is the comparison test. So what I have done over here is, let me bring this down a little bit more. So I have created a variable called as int a and b as 10. So what are the two parts of a memory? The two parts of a memory are stack where the data types are stored and heap where objects are stored. And the rule of the stack is that if a value is already present, all the new variables which has the same value will all point to the same earlier memory location. Okay, so when I say int a is equal to 10 over here, it will go to the stack because this is a data type, and when I say int b is equal to 10 also, it will go down. Both a and b will be pointing to the same memory variable. Okay, so I'm just going to cut whatever I have written over here because I want to run this and show it to you. As you know that we have already done this earlier, you know the story. So I'm just going to paste it here. Let's run this right now. I'm going to save this, and when I run this, you see here that it's going to give me true. But obviously, because like I said, it's going to go down to the stack, and in the stack, if a value is already present, both the variables will point to the same memory address of the first one. That's understood. Now, what am I going to do is I'm going to create two strings. So I'm going to create a string advancer. I'm going to create S2 as advancer. And now what am I going to do over here is, once I do this, let me go ahead and paste it. I'm going to check with the double equal to and the equals. Okay. So first let's go ahead with the double equal to see what would happen. And double equal to will check for the memory location. Now since you have used the word new, and since you know for a fact that objects are stored in heap, and in heap the rule here is every time new means it's a new memory location. So if I check out for S1 double equals to S2, I can comment the earlier one so that we'll see only one output coming in. And when I run this, you will see that it will give me false. But obviously, because the memory location of both of them are different, folks. Okay, so that's how the value was false. That's understood. Now let's go ahead and see the dot equals part of it. So I'm just going to say, in fact, let me just copy this as it is, because I've written some comments over there also. So those comments, yeah, one comment is already here, so I don't need this one. We already have written. So now let me check for S1 dot equals S2. So the equals method in the object class also checks for the memory location. Both of them will check if the values are correct or not. But now the equals method is overridden in the string class to check for the sequence of characters. We have seen that, right? So let me go back to the documentation and show you that the equals method compares the string with another specified object. The result is true if and only if the arguments are not null and is a string object that represents the same sequence of characters. That means it is going to check for the contents. So now if I run these two things over here, you will see that for the first one it will give me false, whereas for the second one it will give me true. It has to give me true because it is going to check for the contents of it. Okay. So now this is the case. Why? Because the equals method was overridden in the string class. So now in case if you have to create, I have finished this, I can delete this. Now what are we going to do over here is I am going to create an instance of my own class. My own class would mean comparison test, the class that you have created. So we are going to have a look at that class and see what the methods are. See here, I create an instance called as comparison test 1 and I create an instance called as comparison test 2. And I'm going to check what is the value of it if I say double equals and if I say dot equals. Double equal to is going to check for the memory location, and since they are objects and since they are new, double equals will always give me false. And when I say equals, the equals method I have not overridden in my comparison test. See, there's no equals method I have over here. Okay, the equals method, that means it will get the equals method from my base class. The base class is the java.lang.object class in which it compares for the memory location. So in both these cases, when I run this, it has to give me as false and false, because in both these cases the memory locations are different because they are objects and I have used the new keyword, friends. Okay. So this is the significance of the dot equals and the double equals, and with specific emphasis to the dot equals, if it is overridden in the child class to give a different behavior, otherwise dot equals and double equals operator will do the same thing, that is checking for the memory location. So that was your comparison operator. Now we will see the last of our operators, that is ternary operator, and you will see this ternary operator used quite a lot in your MapReduce code, so we should understand what this is. Here you are going to look at a Boolean condition. You will put in a question mark, you will give it true, and you will give a false value. So this is how your ternary operator is going to work. So let's take an example to understand what this is. Let me close this out, and I have created a ternary test here. So what I have done over here is I have got a function which is taking two strings in its parameter, and it is going to return me the max of the two numbers that we have passed to it in the parameters. Now, since I cannot compare which is a larger number without converting that into a data type and checking it out, I convert that strings into primitive ints. So the way to do that is there is a class called as integer. It is called as the wrapper class. We'll talk about wrapper classes in the next section, but these are called as wrapper classes. Wrapper means they convert a primitive data type into an object. So these wrapper classes convert the primitive ints into convert the strings into a primitive int. And then what am I doing is I'm using a ternary operator. This is like a modified version of the if-else loop. So I'm having a condition. If this condition evaluates to be true, it will take the first value, or else it will take the second value. And whatever is the value, it will be stored in result. And then I print out and I return the result so that I can capture it in my code wherever I'm calling it and print it out. Then what am I doing? To call this my max function, I create an instance of the class. And to that instance, I'm going to dynamically pass the values. So you would have noticed that in the main function, I am passing string arguments over there. So the string arguments is a string args array. And the reason why those arguments are passed is so that people can pass values to the program when it is running. And even in MapReduce, you will be actually passing a lot of values like this. Okay, so you should understand this concept properly, folks. So we are going to pass two numbers and two strings, in fact, and those strings are nothing but numbers. And the array starts from 0. So how are these arguments passed is at the time when you're running the code, after the class name, space is when the arguments are going to be started. You can do this at command line arguments, or you can do it in the Eclipse when we are running it. I'll be showing it, of course, in the Eclipse how to run this. Plus, I'll also show you in the command line arguments in the next class, so that in the next session, so that you also know how to do that. So two things what we will be seeing it is the wrapper classes and the use of these arguments in the next module. So in this module, what are we going to do is we are going to take up this 0th value, the first value, and then the second value. It will go down to the max function. It will go down to the max function, it will do the calculation, and it will return the value, and then you are printing it out that the max of two numbers are whatever is the value that has been printed out, folks. Okay? So that's what we are doing right now. And to run this, when you say right click and say run as, there is an option called as run configuration. So when you click on this run configuration, we are there in our ternary test, whereas you see over here it is some other class. So you will have to click on this new over here so that it launches a new configuration, and then please be sure that your main class is the class wherein your code is going to be, and in the arguments you will have to pass some values. Let's say I'm going to pass 10 and 50. Space 50 space is how your arguments are separated in the args array. And I will say run, and you will see here that it has gone and it has done the mathematical calculation and said that the max of two numbers that we have provided at runtime is 50. Okay, so let me run this once again. I will say run as, I will say run configuration, I will go down to my arguments. Now I'm going to say 100 and 600, or let's say 600 and 100. So don't think that I'm passing on the higher value in the first instance itself. It could be first or second. You could pass any value what you want. And when you say run, you will see that the ternary operator will return whatever is a higher number of this, and then it will come back in RES and it will print it for you, and you will see over here that the max of the two numbers are 600, folks. Okay? So this is what would end our section on our ternary operator. So with this, folks, we have finished with 1/4 of your syllabus. So you should now know how to go ahead and start with Java Eclipse. You would have downloaded your JDK, but obviously you have to download the documentation and you will have to get used to this documentation. Here is where all the classes are going to be. Here, sorry, packages are going to be. Here the classes and the interfaces is going to be, and you would see the description over here. So this is what is very important for you to know when we start with our MapReduce code, folks. Okay. So with that, let's come down, let's close today's session. So thanks for listening, folks, and please ensure that you are very clear on what we have done till now. So thank you so much, and we will see you in the next session. Bye bye for now.